Okay, in this last part, part C, which is in your lab book, lab 5, page 8, what we're going to look at is kind of the same principle. What we want you to do is focus on using the Chateliers principle. So again, you can't see enough of this, but basically getting the idea that whenever you stress something that's already at equilibrium, it's going to shift to remove that stress and achieve a new equilibrium where that stress has been minimized or somehow absorbed by the system. So again, what you want to focus on is the technician's going to set up an initial equilibrium situation. So that's how we're going to go at this. And make sure you pay attention to what that looks like. Then he's going to do some sort of stress. He's going to, we've ran through this. Remove products, remove reactants, add products, change the temperature. And then you're going to make recordings as far as how the system acts to achieve the new equilibrium. So again, before you continue, make sure you're ready to go here. Pause the video, make sure you got your lab book open, have your notebook ready to make observations. We're going to want to write the balance equation at the top so that as you take your notes, you can study and go, oh, okay, I'm shifting right or I'm shifting left based on what that's doing. So when calcium carbonate, which is an insoluble salt, dissolves in water, it slightly dissolves. It's insoluble, so this thing stays far back to the left. The KSP is very small. You can look in your lab book and see it. Let's see here. It's 3.3 times 10 to the minus 9. So that's true. It's an insoluble salt, barely soluble. What it does disassociate a little bit, make some calcium 2 plus cations dissolved in the water and a little carbonate anions dissolved in the water. And this is the standard way to write a KSP equation. Instead of writing it the other way around, you write it with the solid on the left and the slightly disassociated forms on the right. So you would know the insoluble because that's actually chalk. It's calcium carbonate. It's chalk like we've made in Chem 1 or what you may have seen in your old school days. And then on the right, whenever those ions dissolve, they aren't colored ions, not like a lot of metals. So calcium's clear. So whenever this is in solution, it's a clear solution. Now I need to remind you, go ahead and set up your equilibrium expression. This is good practice again, and I'm not going to fill in the blanks for you. I'll let you do that. That'll be good practice for you. Products raised to the x, reactants raised to the y. I do want to remind you of a reaction that takes place in here that we assume you know, but I do want to remind you how it works. Whenever a carbonate gets treated with acid, so H plus, that's the hydronium ion or the acid, gets in the presence of a carbonate, this is one time the polyatomic ion will come apart. It'll make carbon dioxide gas, and then it will also create liquid water. So you would know this was occurring because if the acid hits the carbonate in solution, you'll start to see it bubbling as the CO2 gas is created. It's also a little test they do if you have minerals that have carbonates in them. They sometimes just drop acid on the rock, and the rock will start gassing off the carbon dioxide. All right, so now we're ready. We're set up, and we're going to let the technician show us how to do Le Chatelier's principle. Okay, so this particular reaction is going to be a little different. You're going to be doing some precipitation, and you're going to spin it down in a centrifuge. So John's got his centrifuge out. He's on track today. He's going for his gloves right away, so that's good. And again, we're working on procedure C, so follow along in the lab book so you know where you're at. This is procedure C, starting on part C, page 8. All right. Setting up his volumetric pipettes. Because remember, we're going to take 3 mils of 1 molar calcium chloride. So this is calcium chloride. There you go. There's the 1 molar calcium chloride. And we're going to so step 1, 3 mils of that. All right, we got it. And again, this is what we call qualitative work. Doesn't have to be exact. But if you pull up 3 mils, dispense it all the way out, that's going to be good for this. Would not be the way you'd do it if you're making a calibration curve, because you'd want to rinse your volumetric pipette. You want to go line to line on your measurements. There you go. All right. 3 mils. Going in, where is it going? I was hoping he's going to put it in his test tube. There it goes. All right. Nice. Got it. We're going to keep that pipette hopefully separate from the other one. Yeah, thank you. Now the other thing is he just pulled that out. Sometimes I push it off with my thumb. That's a little better technique. You can just kind of get your thumb next to the shank on that micro pipetter, was what those green things are called, and you can push it off with your thumb, with your thumbnail. But all right, so now we're getting, this is the sodium carbonate, 1 molar. We're going to put 3 moles of that, or 3 mils of that in another test tube. So you saw the other solution, very clear, right? So here's the sodium carbonate. Puts that off in the test tube. You can also observe this. And we'll see if he lets us see it, but it's a very clear solution as well. So they're both clear solutions. So what he's going to do is he's going to draw one up and put it in the other tube, because you're supposed to mix them together, right? So he's going to just pull it over and put it in the other tube. So he's mixing the 2 tubes together. That's step number 2. I'm not sure why the back and forth on the So now once he puts them together, he's going to get a glass stir rod in there, mix them up real good. So if you wonder how this is happening, what he's doing is he's taking a little at a time from each of the tubes and putting them in a third tube and mixing them. So he's not doing too much at once. So if you just took the two tubes and just, mixed them all in one batch, you might get so it's kind of it's a busy reaction and you might have problems. But now that, okay, this helps. Now you can see what you're doing is you're making the solid. Right? So if you look at your balanced equation, it tends to run left because the K is very low, so it makes a lot of the solid calcium carbonate. All right? So it makes a lot of white precipitate. Can't quite see what he's doing. There we go. Oh yeah, so he's just trying to show you, look. Clear solutions, when you mix them together, you get this solid white milky precipitate. All right? So now what we want to do is we want to actually separate. It's in chemistry 111 you did the same reaction and you could filter that solid off, but what we're going to do in chemistry 2 is we're going to balance our test tubes and make them the same height. So we're going to take a blank tube. That's what he's doing right now. He's blanking a blank tube and making it the same height as that white precipitate tube with just water. And this is just a counterbalance for the centrifuge. It has nothing to do with the chemistry. So that tube you see right there is just calcium carbonate precipitate with a little bit of the unreacted reactants, right? And now he's trying to get the two tubes to the same height so they can put them in the centrifuge and spin them down. So you put those in there, see if he gives us a view, right? You put them on opposite sides so they'll balance each other. And then the blank tube on the left, which just has water at the same height, will weigh about the same. It's kind of like trying to spin a tire. If it's out of balance, that thing would wobble off the table. So he's got it balanced out, seals off the lid. All right, and then basically you just set on, and you got it set at 3,000 RPMs for 3 minutes. And you can, it's hard for you to see, but if you look in that left eye, you can see the numbers crawling up. It's 2,600. Boom, it's at 3,000. So it went really fast. It gets up to speed, gets up to speed really quick. Now it's going to spin here for about 3 minutes. So now through the beauty of chopping the film, 3 minutes of your time just got saved. So now he's done. He's going to pop the lid open and he's able to pull up. That's the counterbalance tube. So he's going to put that somewhere. Not the important tube. There we go. Here's our product. Now look what's happened. See, it's settled all the precipitate down to the bottom and the liquid's on top. All right. So at that point we are we just finished step 3. So now what we're going to do is we're going to reach in there and we're going to grab some of the, he looks like he's going for the fluid layer. Okay. Step 4, draw the clear filtrate, the clear fluid. And what he's going to do with that clear fluid is he's going to split it into 2 tubes and we're going to play with it. We're going to do some different things with it. All right. So you just see how he's drawing it off the top. Trying not to disturb it too much because the solid's all settled on the bottom, and that's fine. Cool. So that's fairly clear he has there. And he's going to set it into, it's a little bit cloudy, but it's mostly clear. And he's going to put it into 2 different tubes. Got his tube stuck. He's like doing that waiter style. Okay, that's good. Yeah, put your tip in there. That's a little safer. And by the way, he's doing that for the video, but you could do it in the test tube rack. That's even safer yet, right? So some of it into one tube. There we go. Yeah, okay. About 1.5 mils each. This is step number 4 in your instructions. Here comes the second part. That goes into this tube. So this can go a lot easier. Just dump the rest over. Cool. So we have them about equal. They're 1.5 mils of each. Right now, there's the leftover precipitate. So now what are the next instructions here? To one of them, we're going to add saturated calcium chloride. That's number 5, step 5. So let's see what happens. Again, look at your reaction sheet. You now have the fluid that's at equilibrium. And now we're going to stress it by adding more calcium chloride. So think about what you're adding when you're adding calcium chloride. All right. Please, yeah, there you go. Stir it, stir it, stir it so we can see what you're doing. There we go. All right, so it clouded up a little bit, made a little bit of precipitate out of there. It's kind of hard to see. And to the other one, so now we're going to work on the other tube, but first he made a little mistake, so he's going to redo this. He's going to get some of that clear fluid and put it back in another tube. So again, that's, it's in step 4 where he split it into 2 tubes. He's just going to redo that. He had enough clear fluid left over, he can do this. So he's going to put that in the tube if he can. There we go. So it's still fairly clear. Good. And now what he's going to do is he's going to work on this step 6. Yep. That's a saturated sodium carbonate. All right, saturated sodium carbonate, and he's going to add that to the tube. This is step 6. And again, look at your balanced reaction, see what happens here. Add some of that. Ooh, all right, so that's definitely precipitating up. Get it mixed so we can really see it. Yeah, that's good for you. That's one of the observations I wanted you to see. So you had the clear filtrate, then we added more of the sodium carbonate. It was able to push the reaction a little bit more. So that finishes step 6. All right. So now we're going to work on step 7. We're going to take hydrochloric acid and we're going to add it to a solution that has both the clear filtrate above and the precipitate below. So there we go. Really important to have your gloves on at this time, right? So there you can go. See this precipitate at the bottom and it's clear up above. Now watch, you add that in there. And if I could see that, now I would tell you to put your attention on the Chem 111 reaction here. This will help you understand this. Because you're actually interacting hydrochloric acid with carbonate, dissolved carbonate anions, and it's going to make something that in essence removes the carbonate anions. So if carbonate's going away, which way is the equilibrium going to shift? We're about to find out. He's having a hard time getting that lid on. Okay, wow. I wish he'd have done a little more shaking, but you can see that it's actually cleared up the precipitate on the bottom. It's cleared up the precipitate on the bottom. All right. So that finishes this step C and parts A, B, and C for this entire lab. So you're ready to start working on your write-up and also try the lab quiz.